Hey everyone, it's Amir Ali. Welcome to Code and Cadet by Sam. Welcome back to the channel, folks. Today we are diving into a super important topic in backend development, a rate limiter in microservices. Now you might be thinking, how do big systems like Amazon or Netflix handle millions of requests without crashing? Or how do they stop hackers and bots from just spamming their servers? Well, the answer is simple, my friend: rate limiting. In this video, I'm going to walk you through what a rate limiter actually is, why it's so important, where you can implement it, and most importantly, how it protects your microservices. So yeah, let's get started. Alright, before we deep dive into rate limiting in microservices, let's quickly look at what we'll be covering in this video. First, we'll understand what a rate limiter actually is, just a simple definition to get us started. Then before we talk about how it works, we'll see the key problems when we don't use a rate limiter, things like server overload, bad user experience, and even DOS attacks. Next, we'll check out how rate limiting helps solve those problems and protects your microservices. And finally, we'll go through how and where you can implement rate limiting in real world systems, like at an API gateway, between services, and even for external API calls. So yeah, stick around. This is going to be an easy to understand guide to one of the most important patterns in distributed systems. Alright, here's a simple definition of rate limiter. Let's break it down in easy terms. A rate limiter in microservices is basically used to control how many requests a user or another service can make in a certain amount of time, like 100 requests per minute, for example. Think of it like a traffic signal, yeah. It only lets a few cars pass at a time. Same way, the rate limiter makes sure requests flow in a controlled manner. This way, it stops people or even bots from sending too many requests all at once. It prevents abuse, makes sure everyone gets a fair chance to use the system, protects backend services from crashing, and keeps everything running smoothly and reliably. Okay, now let's take a simple example in this slide. In a typical e-commerce website, users interact with the backend through services like the product service. So imagine a user sends a request to fetch product information, for example, product 123. That request goes to one of the backend servers hosting the product service. It pulls the data from the database and then sends it back to the user. Everything works nice and smooth, efficient also, when the number of requests is low or under control. But think a bit, what happens when traffic spikes suddenly? Let's say a single user, or even worse, a hacker or malicious bot, starts sending thousands of requests per minute, trying to fetch product 123 or product 1234 and many more. This hacker might even attempt to send unlimited requests in a short span of time, trying to overwhelm the system. Each of these requests is routed to one of the backend servers, and all of them hit the shared database. Without any control or restriction in place, the system begins to struggle. This leads to several critical issues. Server overload. The backend servers get flooded, consuming CPU and memory rapidly. Poor user experience. Genuine users start facing timeouts, slow responses, because servers are too busy handling spammy traffic. Risk of DOS attacks. This kind of unchecked behavior can easily lead to a denial of service, taking down the entire system. Unfair usage. One malicious actor hogs all the resources while others are left behind, making the system unreliable and unfair. And this is exactly where rate limiting comes in, to protect the system, ensure fair usage, and maintain a stable user experience for everyone. Now let's implement a rate limiter in our e-commerce website. We have added a powerful layer of protection between the incoming traffic and our backend servers. Here's how it works. Whenever a client, whether it's a genuine user or even a hacker, sends a request like product 123, That request first passes through the rate limiter. We've configured the rate limiter to allow only 100 requests per minute per user. If the client stays within that limit, the rate limiter simply lets the requests flow to the backend servers, which then talk to the database and return the proper response. Nice and smooth. But if the client goes beyond 100 requests per minute, the rate limiter blocks the extra traffic right there, stopping it before it even touches the backend. This way the system doesn't get overwhelmed. For example, if a hacker tries to blast unlimited requests to flood the system, the rate limiter catches this behavior and cuts off the extra traffic, keeping the backend safe and responsive. Even if a normal user or maybe some automated script accidentally goes over the limit, they'll simply get a response like 429 too many requests, which means they've hit the cap and need to wait before sending more. And this mechanism gives us some solid benefits. Stable server performance. The server won't crash or slow down even under heavy usage. Protection against DOS attacks. Hackers get blocked before any harm is done. Fair usage for everyone. One person can't hog all the resources. Better user experience. Genuine users enjoy faster, smoother responses. So yeah, with rate limiting in place, we now have a smart gatekeeper making sure our backend services and database are used responsibly and stay healthy, no matter how many users are on the platform. Alright, so now the big question, where do we actually implement this rate limiter in a real system? Well, there are three main spots. Let me break it down for you. At the API gateway. This is like the main entry door of your system where all client requests first arrive. The rate limiter here makes sure nobody overloads the entire backend. The API gateway checks how many requests each user or IP is sending. If it's within the allowed limit, say 100 requests per minute, the request goes forward to backend services. If it's above the limit, boom, it immediately returns a 429 too many requests response. That way nothing spammy goes deeper inside your system, keeping everything safe and stable. On internal service calls, this one's inside your own architecture, like when service A talks to service B. Imagine service A has a bug and it starts hammering service B with non-stop requests. Without a limiter, service B could get overloaded. So here you add a rate limiter on service B. It monitors how many requests it's getting from other services. You can even limit it by service identity, user context, or endpoint type. This protects one service from dragging down another. On external API calls. Finally, when your backend calls third-party APIs like payment gateways, Google Maps, or social login, these external services usually have strict limits like 60 calls per minute. If you go beyond that, they might block you or even charge extra. So what do? Before making the call, your service checks how many requests have already been made in that time window. If you're under the limit, the call goes through. If not, you either wait, queue the request, or fail gracefully with a friendly message like try again later. So yeah, API gateway, internal service calls, and external API calls. These are the three sweet spots where rate limiting really shines. That way your system stays safe, fair, and super reliable. Alright, that's a wrap for today's video on rate limiting microservices. We talked about what a rate limiter is, why it's so important, the problems it solves, and the different places you can implement it. API gateway, between services, and even external API calls. Remember, without rate limiting, your system can easily get overloaded, slow, or even crash. But with it, your backend stays safe, fast, and fair for everyone. So yeah, hope this made things super clear for you. If you found this helpful, don't forget to hit that like button, subscribe to the channel, and share it with your dev buddies. I'll see you in the next one. Until then, keep learning, keep building, and stay awesome.